Okay, this will be the last problem that I'm going to do on this set. Chapter 17, I figured I would do a base problem. And a base problem, we calculate the pH of a solution by adding ammonia. So again, I'm going to start with my equation at equilibrium. Ammonia is NH3. NH3 acts as a base. So the water is donating an H to the base. On the other side, you get ammonium, which is your conjugate acid. This is weak, and your base is weak. Okay, and you're producing hydroxide. Nothing's happened right now, so you don't have any hydroxide. Initially, you're throwing in 0.15 molar ammonia, and the ammonium acetate, okay, I'm going to change that. Should have changed it. I meant chloride. Definitely want to change that to chloride. Okay, so is 0.12 molar. Okay, I just kind of made the problem up from the last one, which was an acetic acid problem. Okay, the reason you don't want to use acetate is that's a salt of a weak base, and I want my counter ion to ammonium to be a spectator ion, which is just chloride. It's not in the equilibrium, and it's not going to affect it. Acetate actually would shift it by making acetic acid. All right, but chloride's not going to react with water to make a strong acid, hydrochloric acid. Okay, in the opposite direction, the H would go back to the OH. Now the biggest thing is when you get to a problem and you see that you have a weak base and you have a weak acid, that's Henderson-Hasselbalch. So this time I'm going to pull out the base version of Henderson-Hasselbalch, which everything's in opposite world. POH equals the pKb, and now on top is the concentration of your acid, your weak acid, and your weak base is on the bottom. Okay, so the last term, the weak acid and weak base are going to be the log of ammonium over ammonia. Okay, the pKb, we'll just rewrite that as negative log of 1.8 times 10 to the negative fifth plus the log of 0.12 over 0.15. This number is 4.74, and this number comes out to be plus or negative 0.01. So your pH hasn't changed a lot. That's what buffers are all about. It's 4.73, and that's the POH. I don't know if I just misspoke. So POH is 4.73. Now, if I was starting this problem, I notice it's a base buffer. So I would predict before I even started that my answer should be between 8 and 10. Good labeling is what it's all about. Label that as a POH, and then you know to find the pH, you got to subtract 14 minus 4.73. So the pH equals 7. Yeah, I'm thinking I have tape. So 14 minus 4.73. Equals 9.27. And that's where I would have expected it to be, between 8 and 10. And that's your answer. Okay.